Okay, let's take a look at some other versions of solving radicals. If you notice on these two examples, you actually have two radicals. So if that happens, if you ever have two radicals, the steps are to put them on opposite sides and then do your power and solve. So in this case, the first one here, we got the square root of 7x plus 4 equals the square root of 3x plus 8. So since I already have the radicals on opposite sides, I'm going to undo the root by doing the square power to both sides. And remember that squares and square roots are opposites or inverses, so they will cancel out. And then from here, I'm going to solve. So I'd be subtracting 4 here, and that would give me 4. So x becomes 1. Now, once I get this, I do want to make sure my answers are working out and I don't have anything extraneous. So we're going to double check our answers. Always good habit. So let's see if we get the same amount. So 7 times 1 plus 4 is 11. And 3 times 1 plus 8 is also 11. Now, I realize they're under the square root sign, and you're probably thinking, I don't know how much the square root of 11 is. That's okay. All we're looking at is that they came out to be the same amount, and they did. Second example over here is with cube roots. So again, we have two cube roots, and they're on opposite sides, which is what we want. And then we take and undo the root by doing the power. So since this is cube root, we will do third power to both. And we will subtract that 3x over. We will subtract that 2. And if we divide, we get x is negative 6. And like I said earlier, it's not so much of an issue on odd roots, but it is a good habit to double check your answers. So we will go ahead and double check this and make sure we get the same amount. So negative 30 and plus 2 would be negative 28, and on the other side, let's see, that'd be negative 18 minus 10, which is negative 28, which is a good thing. Okay, so we got the first one here is x equals 1, and the second one is x equals